Okay guys, just want to make a short video of one error that I found on most people's labs today. Just so you're familiar with my setup, I've got my first power supply here set up to 98 millivolts, and you've got your positive and negative voltage rail. And if you look here on the circuit, you're going to see how everything's wired up. So for the first circuit, if you remember, this is your 2.2K coming from your input. Then you have your 22 kilo ohm that goes from your output back to your input. Okay. Now the critical mistake that most teams make, which I apologize for not catching it, I was kind of spread too thin today, was that pin 3 on your op amp needs to go to ground. Okay, so let's look at the schematic. So if you look at the schematic here, here's my input. Okay, we were missing this critical component, this ground. Okay, let me show you what happens if you do not have the ground in your signal. Okay, into your chip rather, excuse me. So currently I do have ground of pin 3 of the chip, and if you notice on my voltage output, I'm reading 0.98 volts. That's a gain of 10. Okay, that is exactly what we should have, because we have a 22 kilo ohm feedback resistor and a 2 kilo ohm input resistance. Now look what happens. I'm going to be loosening the ground wire while I'm focusing on the voltmeter. Look what happens. Now the wire is not to ground. Look, that is 9.8 volts DC. I'll do it again. I'm connecting pin number 3. I go back to 0.98. Okay, now that was our first critical mistake. So if you have values of 9.8 volts on your write-up, that's okay. Please just make a note that the error in your circuit was that pin number 3 of the op amp was not grounded. Now, let's go ahead and look at video number 2 that's going to explain the comparator circuit and what you should be getting. So let's please look at video number 2 for that.